In this recording, I will show how to simplify radicals. Here's the first example that asks you to simplify. It's a square root, since you don't have an index here, of 12. You can try to put the square root of 12 in your calculator and it should give you a decimal. And that is because you cannot find a whole number that, if multiplied by itself, would return you a 12. With that, here is the procedure to simplify the square root of 12. Think about a pair of numbers that multiply to 12. There are a couple of options for 12. It can be 2 times 6, it can be 3 times 4. It really does not matter how you begin breaking your 12 down, as long as the two numbers that you choose multiply to 12. I'm going to do 2 times 6. Now look at the two numbers that you have at your breakdown, 2 and 6. Ask yourself, can I break either one of them down even further? The answer is yes and no. 2 does not break anymore. It's a prime number, so I'm going to highlight that. But 6 breaks down more into 2 times 3. Now ask yourself if the two numbers that you obtained from 6 can be broken down more. The answer is no. 2 is prime and 3 is prime. With that, the breakdown for 12 consists of the three highlighted numbers, 2, 2, and 3. Notice I am not using 6 because 6 was broken down more. We are only using the highlighted numbers. Among the highlighted numbers, you are now looking for a pair or pairs of numbers that match. Here you only have one pair of 2's. And when you write in the answer to the simplified version of square root of 12, you will take one number from that pair and place it to the front of your answer. So the 2, because we had a pair, goes to the front. And everything that does not have a pair, in our case it's a 3, goes back under the root. And that's it. You just simplify the square root of 12. The answer is 2 square root of 3. Here is another example. 125 is not a perfect square, so to find the square root of 125, you have to break it down similarly to 12. I'm going to say it's 5 times 25. 5 does not break anymore, so I highlight that, but 25 breaks into two more 5s because 5 times 5 is 25, and that's it for the breakdown. I am not highlighting 25 because I broke it down more. So you have a 5, and another 5 for 125. And you can always check by multiplying these three numbers and see if you get this number under the root. You're now looking for numbers that make up pairs of matching numbers. You have one pair of 5's here, and then you have the third 5 that does not have a pair. Remember, a number from the pair goes to the front of your answer, and the number that did not make a pair goes back under. Here is another example. This one also has a variable, square root of 128x. We will look at 128 and x separately. So I will first break down my 128 similarly to numbers 1 and 2. So 128 can be broken down into 2 and 64. 2 does not break anymore, but 64 does. It's 2 and 32. So now for the 32, you could do 2 and 16. Again, 2 cannot be broken down anymore. For 16, it's 2 and 8. This 2 cannot be broken down anymore. This 8 is 2 and 4. And then finally, 4 is 2 times 2. And that is your breakdown for 128. Remember, in the breakdown, we're going to be pairing matching numbers. Here you have several pairs. So you got this pair of 2's, and one pair from that 2 will go outside. There's another pair of 2's. Another 2 from this pair will go outside. And then another pair of 2's right here, and the 2 from that pair will also go outside. So all in all, you have 3 2's to go outside. To put all three of them outside of your answer, you will simply multiply them together. So you'll be multiplying 2 times 2 times 2, which is 8. The two that did not get paired up, which is this two right here, will be placed back under the root. Now this is for 128. For the x, because it's just a single x and not x squared or x cubed, etc., you cannot break it down. You cannot make any pairs. So that x will be staying back under the radical with the 2. That's your answer. Let's look at number 4. Here is another example of the simplifying square root. You have square root of 9x to the power of 19, y to the power of 5. Again, we will be doing 9 separately, x to the power of 19 separately, and y to the power of 5 separately. So square root of 9, you can try on a calculator and that will give you a 3, or choose to do it the pairs way like we have been doing. You can break it down into 3 times 3. And because each 3 is prime and you cannot break it down anymore, you're ready to pair up your numbers. So inside of the 9, you have one pair of 3's, which means that 3 will go outside. And since there are no numbers that did not get a pair, there will be no numbers left under the root from the 9. Now let's deal with x to the power of 19. X to the power of 19 means x multiplied by itself 19 times. So I'm going to go ahead and write out 19x's. Here you have 19x's for the breakdown of x to the power of 19. I'm going to be doing the exact same thing I have been doing with the numbers, meaning I will be pairing x's 2 at a time and pulling one x from each pair to go outside of our radical in our answer. So from this picture, you can see that I have 9 green x's to go to the front of your answer and join this 3 that we already know will be in the front of our answer. So 9 of these green x's will make you x to the power of 9. And then the x that did not make a pair, which is this last x at the end, will go back under the root. And that is the simplified version of x to the power of 19. Very similarly, I will now write out 5 y's for this y to the power of 5, and we will pair up the y's and pull whatever we can to the front, and then the remaining y's that do not make a pair will stay back under the root. So from the y breakdown, you have 2 y's or y squared to go outside. And then the last y, which is this y here, will go back under the root because there is no pair for it. So now we have to put all 3 of these answers together. The one from the 9, the one from x to the power of 19, and the one from y to the power of 5. So the 3 is outside, the x to the power of 9 is outside, and also y to the power of 2 is outside. Back under the root, you have an x and a y, and this is your simplified version. Here is an example of a radical that is not a square root. This is the 5th root, because you see the little index here on the shelf of the root, and that's 5. The idea behind simplifying roots with higher indexes is exactly the same. You still have to break down what you have underneath the radical, and then you will be circling. But the number of items in each circle is shown by this index. So for square roots, we were circling 2 at a time, but for the 5th root, we will be circling 5 at a time. So let's go ahead and break down x to the power of 12. Here are your 12 x's, and I will be circling 5 of them at a time. There is 1, and there is 2. So since we have 2 circles, we will be pulling 2 x's or x squared outside of your answer. The remaining x's that did not get circled, which are these 2 x's here, will have to go back under the root. And you will also multiply them together. So it's also x to the power of 2 because you have 2 uncircled x's. They will go back under the root. And please make sure that when you're writing or typing your answer, you keep your root as a 5th root. It does not magically turn into a square root. Do not forget that index. So the next few questions will ask you to add or subtract expressions that contain radicals. When it comes to adding or subtracting expressions with roots, it's very, very similar to combining like terms. So what you need to make sure you have is the same exact looking radical in all of the terms. And in that case, you will be combining the numbers that are in the front of those radicals. Clearly here you have identical square roots of x in each term. So all you have to do is add 14 and 10, which will make you 24, and you keep the radical that was next to those two the same. Here's another addition and subtraction. This one has 3 terms, and the roots are only the same in first 2 terms. The 18 has a root 2 next to it, and then the 3 has root 2 next to it. Those two can be combined together. 18 plus 3 is 21, and root 2 stays the same. You don't actually add the numbers that were under the roots, and that's the whole point of having them match, so that you can just drag it into your answer. The third term with the square root of 3 here does not match, so we have to bring it down into our answer, but you cannot actually combine it with the 21 square root of 2. So this here would be the simplified version. Here's another addition example. As you can see, the roots are completely different. The first term has square root of 5 and the second term has square root of 80. So you cannot simplify this expression. However, what you could try to do is simplify square root of 80 separately and see, maybe the breakdown will allow you to have the root that matches to the term here. So let's go ahead and break 80 down. I went ahead and highlighted all of the numbers on the ends of our breakdown. We have 2, 2, 2, 2, and 5. It's a square root, so I will be circling pairs. One number from each pair will go outside, so you got a 2 and a 2, you multiply them together, it's a 4. And then the number that did not get a pair, this 5, goes back under the root. So 4 square root of 5 is the simplified version of square root of 80. I will go ahead and bring down this term here, 5 square root of 5, and then this plus here. So now you're simplifying 5 square root of 5 plus 4 square root of 5, and you are allowed to add a 5 and a 4 here because their roots are exactly the same. So the answer is 9 square root of 5. Here's the last final addition example. Again, these roots are completely different, and you are only allowed to combine like terms if the roots are exactly the same. So let's go ahead and break down the 40 and 625 and see, maybe that will make them match. For 40, here's your breakdown. So inside of the 40 you have 3 2's and a 5, and because this root is a cubed root, you will be circling 3 matching numbers at a time. So 2 will go to the front, 5 will stay back under the root, and make sure that you keep your root cube root. Don't magically change it into square root. Don't forget that index. Let's go ahead and look at 625. So for 625, here is your breakdown. You have 4 5's inside of 625. 3 of them will make you a circle. 1 5 from that circle will travel outside. And the 5 that does not have a circle will stay back under the cubed root. And that is the simplified version of cubed root of 625. Now notice something here. That cube root of 625 had this 8 in front of it. So that 8 and the 5 that you had taken outside, in addition to the 8 that was already outside, need to be multiplied by each other. So plus 40 cube root of 5. Now the numbers under the cube roots are matching, which means we are allowed to go ahead and combine like terms. This will be a 42 cube root of 5. One quick remark before I end this recording is the way of writing roots as rational exponents. Rational means a fraction. So any kind of root, and I'm going to write a formula here. Let's say you have a number under the root, and that root has the index of b. Now that b can be 2 or 3 or 4, just whatever that root is. And let's say a has its own exponent of c. Again, this can be 1, 2, 3, etc. So this expression here can be written as an exponent. So you keep your base, a the same, but the exponent is going to be a fraction, c over b. And it works both ways. So if you're given this expression here with the rational exponent, you can write that as the root with the index and the exponent on the inside. For example, an x that has the power of 9 over 14, so 9 here would be your c, and 14 here would be your b, you can write this expression using the root. So you're going to write your root, you're going to put your x under that root, and whatever number is on the top of the fraction, so minus 9, and that's the c, and c is the exponent of the x on the inside of the root. And then the bottom number, which minus 14, and that's your b, and that will be the index of the root. So my root is 14th root of x to the power of 9. Here's another example that asks you to simplify. It gives you a base 100 with the rational exponents 3 over 2. So comparing it to our formula, the 3 is on the top, and that will be the power of 100 inside of the root. And then the 2 is here on the bottom, that's your b, that's the index. So writing this as a radical, you're going to have 100 under the radical. The index of the root is 2, so that's a square root. And you don't have to write that 2, but for demonstration, I'm writing the square root of 100, and the power of 100 is the 3. So this actually can be simplified. And what I will do is I will first find the square root of 100, and we know what that is. Square root of 100 is 10. So the green circle equals to 10, and then you're going to take this power and apply it to the 10. So 10 to the third is 1000. And here is the final example. So 256 to the power of negative 1/4. To make that 1/4 positive, all you have to do is flip the base. So all you have is 1 over 256 to that power of 1/4. Keeping the 1 on the top, I will write my rational exponent as a root. It's going to be 4th root of 256 to the power of 1. So I will go ahead and find 4th root of 256 first, and that is a 4. So you're working with 1 over 4 to the power of 1, and 4 to the power of 1 is just a 4, so that's 1/4.